Hey everybody, it's Erik, co-founder, partner of Village Global, a network-driven venture firm. And this is Venture Stories, a podcast covering topics relating to tech and business with world-leading experts. Hey everybody, welcome to another episode of Venture Stories by Village Global. I'm here today joined by a very special guest, Nathan Cheng. Nathan is the program director of On Deck Longevity Biotech, and we're here to talk about the new program and more broadly, the past, present, and future of longevity. Nathan, thanks for coming on the podcast.
Thanks, Erik. Always happy to be talking about longevity, and super excited to share what we're building with the fellowship program at On Deck.
Awesome. So just to zoom out, why don't you tell us a bit of background of how you got involved in the space?
I'm also the founder of the Longevity Market Cap newsletter, which is basically a once a week sort of roundup of developments in the longevity space. I also have a website called Longevity List, which is a place where people can find jobs and companies and investors in longevity. I also have a podcast, which is the Longevity Biotech Show, and also have this forum, longevity-based forum, which is kind of like a open stack exchange for aging biology and longevity biotech. To answer your question about how I got involved in this space, I could actually come from a bit of a non-traditional background. So I started off actually in physics. I was 2 years into a PhD program, and I had this sort of existential crisis, the typical, what's the point of doing anything? What's the meaning of life? Sort of wrestling with the ephemeral nature of life, I guess. And I actually ended up dropping out of my PhD program. And after that, I just went backpacking around the world for about 1.5 years. I ended up working in Australia. I spent a couple of years in China working there too. I did some internet marketing, got into crypto, did a lot of random stuff, but, ended up making a huge circle without really figuring out the answers to my questions. A couple of years ago, I realized that I already knew about, sort of like the anti-aging space. Like I knew about Aubrey de Grey and for some time, and his ideas around, aging being basically an accumulation of damage that could be repaired. I thought it was a cool idea, but I never really thought that I could do something about it. I figured that was, something that other people would work on. But there was a time a couple of years ago that I watched a YouTube video where Laura Deming was talking about how lots of capital was flowing into the longevity space compared to years before, but that there wasn't enough founders. So naturally, I thought to myself, aha, she's talking to me. I'll be a biotech founder in the longevity space. But of course, I didn't actually have a background in biology. I never even took high school biology. So I thought, okay, maybe I'll do something about this. So I ended up taking some, online courses on biology and just learning more about the space, reading some more books. And then I guess last year I started the Longevity Market Cap newsletter. And this was actually just a way for myself to learn about the space, just figure out what all the different companies were and like the different approaches that they were taking to, tackling the problem of aging. And so the newsletter actually started off really slowly at first, but then sort of took off. It was doubling. The subscriber count was doubling like every 7 to 8 weeks. And at some point, I realized, hey, this is actually something. And maybe the way that I can use my efforts right now or direct my efforts would be not to build a single biotech company by myself, even though I'm thinking about this in the future. But actually, maybe the correct thing to do right now is to try and convince maybe 100 people to start longevity biotech companies. So this has been like really my sort of mission that I've taken upon myself, just to spread awareness about the space and get more people involved, either like building companies or joining them or investing in longevity biotech companies.
That's awesome. Can you give a bit of background on the history of longevity and where we are now?
Yeah, sure. So I guess you could say that the science of aging that maybe started in the modern era was probably, it's probably started in the 1930s. So Clive McKay did a couple of experiments in rats where it would calorically restrict the rats. So basically, feed them a lot less than normal. And they actually found that extended their lifespan by about like 33%. And more importantly, they found that also the rats that were calorically restricted, were just more youthful. They suffered less from sort of age-related diseases than the control rats. So that was a really interesting sort of observation. But I guess you could fast forward. The next sort of like breakthrough in the science of aging would be by Cynthia Kenyon in 1993. So Cynthia was doing work on C. elegans, which is a type of worm, and she was extending kind of some of the previous work by Thomas Johnson, and she found that there was a single mutation in these worms that could actually double its lifespan. And of course, this was sensational, and it sparked sort of like an intensive study into the molecular genetics of aging. So another sort of breakthrough happened in 2005 by Tom Rando when he was at Stanford. And basically, they were doing these experiments in heterochronic parabiosis. So basically, they would sort of like surgically attach two mice together, one old and one young. And what they found was actually that the blood from the young mice had rejuvenating effects on the old mice. And so there's a lot of work being done on this sort of approach for anti-aging right now. Another cool thing that happened was maybe in 2006, Shinya Yamanaka, he found a set of 4 genes that when activated could actually return a cell, like an old cell, back to its young embryonic state. And this is called induced pluripotency. And it basically sort of set off the stem cell revolution, and also, is the approach that a lot of the cellular reprogramming or epigenetic reprogramming startups in the anti-aging field are sort of pursuing right now.
What's the state of the stem cell revolution, by the way?
Yeah, so the stem cell revolution is still very much in progress. Back in the 2000s, there was a lot of hype about stem cells and just their ability, maybe, or the potential to be used in tissue engineering and lab-grown organs, that kind of stuff. And this was even before the discovery of induced pluripotency. But today, there's still, a lot of challenges that need to be overcome before we can, sort of attain that holy grail of regenerative medicine with stem cells. So some of these challenges include like just being able to differentiate these cells into the right sort of cell types, and also like vascularization of engineered tissues, and the creation of like the 3D scaffolds that are needed to grow engineered tissues. These are all things that people are working on, and I'm optimistic about the use of stem cells and for like tissue engineering in the longevity industry in the future. So other than stem cells, I guess in 2009, there was another big breakthrough. So some groups were able to demonstrate that a simple drug called rapamycin was able to increase the lifespan of mice by about 15%. And this result has been replicated many times. It's very robust. And now people like Matt Kaberlein at the University of Washington is, using this drug in a small study for dogs. It's called the Dog Aging Project. And basically, they're trying to see if, maybe this drug also works to extend lifespan in dogs. So that's really exciting. And then I guess the most recent sort of breakthrough in the science of longevity and maybe the translational science for some of these therapeutics, that came in, I guess, 2016. So scientists at the Mayo Clinic at the Van Dersen lab were basically able to show that the clearance of senescent cells could modulate aging. Senescent cells are basically these zombie cells that lose the ability to divide, but they end up secreting these like sort of inflammatory factors that are sort of pro-aging. And in this experiment, they removed the senescent cells, these naturally occurring senescent cells, and they found that in mice, when you remove these cells, they live, somewhere between 27% to like 40% longer. The treated mice also had like a more youthful appearance, and the tissues of the treated mice were just younger. The mice had like delayed cataract formation, and so this was like a huge breakthrough. And the result actually ended up launching like over 24 companies that were also looking into this space of removing senescent cells. So this is a very hot space in the longevity biotech sector. So that's sort of the history. But so where are we now? I would say there's a bunch of different companies trying different approaches to modulating aging in humans. So trying to develop different therapies to treat aging. But we have a bunch of different clinical trials in progress, about like 40 different trials, I would say, for therapies that target aging in some sort of way. We're basically waiting for the first success in humans, like a proof of concept in humans, like the first 0 to 1. And once we achieve that, I think this space will really, really take off.
Totally. Thanks for that. Thanks for the overview. Zooming out a bit, what are some of the bigger misconceptions people have about longevity and life extension more broadly?
So that's a good question. There are so many. So first of all, the one thing that most people don't know about the longevity biotech industry is that it even exists at all. It's very much a new frontier, like a nascent field, both in the science and the biotechnology. I think people don't really know, they're not aware that there are over, 100 biotech companies developing therapies that target aging. People don't know that, there are drugs being developed in the context of aging that are actually in clinical trials as we speak, right? There's about maybe 40 different clinical trials underway. So that's one thing. But I think the number one sort of misconception that holds back progress in the field would be that there's this myth that extending lifespan will result in extending the time spent in sort of like an old, frail, decrepit state. So, when people see older people, decline in health from like 50 years, to 90 years old, they assume that therapies that extend lifespan will just extrapolate that trend, so that when you go from like 100 to 120, you'll just be even more old and even more frail. But actually, the whole point of the longevity biotechnology industry is to increase lifespan and health span by targeting the aging process itself. We're trying to make people biologically younger for longer, which will translate into less suffering from age-related diseases and extend lifespan. So another myth, actually, that we should address is that aging and age-related diseases, such as like Alzheimer's disease, cardiovascular disease, and a lot of cancers, are something separate from aging. When actually, in fact, the diseases of aging are aging, right? They're late life manifestations of the biological process of aging. And so a lot of people will tell me, hey, we shouldn't be focusing on aging. We should probably focus on curing cancer or Alzheimer's first, right? And I like to tell them, well, actually, in the longevity industry, we are doing exactly that. We're just trying to target these diseases or treat these diseases at like a place higher upstream, right? At the root cause, which is aging, because a lot of these diseases, like Alzheimer's disease, cardiovascular disease, the risk factor goes up exponentially as you age. So this sort of leads us to the geroscience hypothesis, which is basically that a single therapeutic intervention working on some pathway of aging might possibly treat multiple different diseases of aging. And this is like a very, very powerful sort of way to address, these sort of outstanding issues in health and, age-related disease. But I think last but not least, a major misconception is that extending healthy human lifespan is somehow morally wrong or whatever because it's unnatural. And I get this one a lot on Twitter. And for that, I just say, we've actually already doubled human lifespan once in history, right? By developing technologies like antibiotics and sanitation. And nobody objects to those interventions today, or so those inventions today. And so I think people should really see anti-aging therapies as something that is like a preventative medicine. And I think everybody can get on board for that. But, other than those major, misconception, there's a bunch of other like small sort of, niggling sort of objections that a lot of people will say that, that are easily, dismissed. But like, for instance, a lot of people will say, oh, if we extend lifespan, then we'll end up having, overpopulation, which I don't think is true. Actually, underpopulation is the bigger threat. Most wealthy countries already are below replacement rates in terms of fertility. And, when developing countries eventually become more wealthy, I think that trend will also hold true. There's other crazy sort of misconceptions that, longevity and extended lifespans will make dictators immortal. And of course, that's not true. Longevity and immortality are not the same thing at all. You can still, be hit by a bus. That's not, longevity therapeutics don't change that risk or whatever. And, authoritarian regimes already exist. So there's already ways for, dictators to somewhat be immortal. So that's not like a good objection to developing longevity therapeutics. And then, of course, there's like crazy, objections like, oh, life extension will doom people to, boredom, which is just like completely insane. I mean, all of these problems are very superficial compared to like the sheer scale and size of the problem of biological aging, right? There's just so much suffering involved with, age-related disease. So, I mean, just to summarize, I guess the big misconceptions are, we need more people to be aware that the longevity biotech industry exists. We need more people to be aware that, rejuvenation therapies extend lifespan by, increasing healthy lifespan, not the sick span. We need more people to be aware that age-related diseases like, Alzheimer's disease, cardiovascular disease, and many cancers are actually manifestations of aging. So they are aging. And we could potentially treat all of them at once by treating, aging as the root cause. And of course, last, we need more people to realize that longevity is not just some weird fringe thing. It's, something everybody can get behind. And if you believe that developing therapies that prevent disease is a good thing, then you'll love longevity, you totally, support the cause.
Yeah. What are some of the big challenges or roadblocks in the space right now?
Okay. Yeah. So definitely the biggest challenge in the industry is lack of founders. So there's been a lot of new capital flowing into this space, but we still have a huge bottleneck, which is, lack of founders. And in recent time, just a couple months ago, like Michael Grev at Kazoo Technology Capital, he announced that they would be investing $350 million into, rejuvenation startups. Google and, their anti-aging sort of subsidiary Calico has teamed up with AbbVie, which is a big pharma giant. And they've, invested billions of dollars into this space. Sergey Young has a $100 million longevity vision fund. Aubrey de Grey has been dropping some massive hints about a certain, very well-known someone who's about to get involved in funding this industry. It's pretty obvious who he's talking about. But there's a lot of money coming into this space, but I don't think it can be absorbed by just the existing companies. So you'll often see VC firms that actually have to build a company around like an asset or like an academic researcher, because there's just not enough companies to invest in. So we really need more founders, and Laura Deming talks about this, and everybody else knows who's in this industry knows that the big bottleneck is founders. And so what can you do about that? I mean, why are there so few founders? Well, as we talked about before, I think that not a lot of people know that the longevity biotech industry exists. So just raising awareness about that, I think, would really help. But aside from that, there's also sort of like a big misconception that you need to have like a traditional biotech background to get involved in the longevity industry. And I don't think that's true at all. In fact, like empirically speaking, many of the key leaders in our field did not come from biotech or even had like a formal biology training. So some examples. So Ben Kamens, he's the founder of Spring Discovery, which develops longevity drugs using AI and machine learning. Who else is there? There's Matt Scholes, who is the co-founder of Oishin Biotechnologies. Who else is there? Reason, he's a co-founder at Repair Biotechnologies. We have Joe Betts-Lacroix, who is the founder of Retro Bioscience. And even Aubrey de Grey himself, did not come from a formal biology training. And he's sort of like the founder of this field, right? So you definitely don't need formal biology training to get involved. You can always learn, and of course, now's a great time to be able to learn on your own a lot of this stuff. But other than that, I think there's also a misconception that you need a PhD to start like a biotech company. So, a great example that's not true is Celine, right? Celine Haliua of Loyal, which is like one of the most interesting longevity startups. Basically, they're trying to reverse aging in dogs first and then translate to humans. So that's super exciting. Some other challenges in the field, in our industry at least, is that just in general, biotech is really hard. So it often requires a lot of deep expertise to navigate, the science, the technical aspects, the business development, and also there's a large part which is regulatory. And I think that's to solve this problem, you need to pair more founders with experienced mentors. So people from the pharma industry who have like very deep long experience in drug discovery and the regulatory aspects of biotech. You need to pair founders with VCs, the space, and also other founders, like other experienced founders. I think that's really what's necessary, because a lot of this stuff you can't really learn on your own. People aren't really writing about how to build biotech companies, I think.
Totally. That makes a lot of sense. So why don't we segue a little bit to the On Deck Longevity Biotech Fellowship? What sort of the details and what will people get out of it, and what types of people do they have to be in the industry or outside of the industry? Why don't you talk about that?
Yeah, sure. So the On Deck Longevity Biotech Fellowship has a very simple mission, and that's to increase the number of people working to build longevity biotech companies. So there's a lot of people who are interested in longevity, but may hesitate to get involved because either they don't know how to get involved, or they feel like they don't have the right experience to make an impact. And on top of that, like we talked about before, biotech is just hard. There's not as much information out there on how to build a biotech startup. So the goal for the On Deck Longevity Biotech Fellowship is to make it as easy as possible for people to come build biotech companies in longevity. And once they are part of the fellowship community, we will support them throughout their entire journey in building the future of longevity. Okay, so how does this work? How are we going to do it? The Longevity Biotech Fellowship basically take in the most talented people looking to build longevity biotech startups, as well as a number of people looking to join or invest in longevity companies. And we put them all together in a community of peers and expert mentors. So the fellowship runs all year long, and it combines talks from world-class speakers from industry and academia. We'll have tactical workshops on biotech entrepreneurship, networking and social events, mastermind groups. We'll have pitch competitions, curated connections with investors, and office hours with mentors, including experienced longevity founders, seasoned pharma veterans, venture capitalists, and top researchers in longevity. So I'm really excited about the fellowship community that we're building, and I can't wait to see what kind of companies and connections are formed from it. I guess looking long term, we want the On Deck Biotech Longevity Biotech Fellowship to be the go-to place for people who want to connect and build incredible companies together in a community that is laser focused on longevity.
What's the why now?
Yeah, good question. I mean, generally speaking, I think now is the right time to get involved in longevity because investors in society are just beginning to wake up to this idea that we can intervene in aging. The science is definitely ready for translation, right? Most of the discoveries that we discussed earlier in the history of longevity, those occurred maybe like 10 to 20 years ago. And so there's just been enough time for, these different approaches to work through the labs and finally get to private industry to be, translated in clinical trials. So yeah, definitely the science is ready. Also, just in general, the growth opportunity in this sector will be just tremendous, especially in this, coming decade. The need is definitely there. World populations are getting older. The healthcare burden from age-related diseases is probably going to, increase significantly throughout the coming decades. So I think working on longevity is really just kind of like one of the highest leverage things you can do right now. And obviously, reversing aging is probably the biggest idea in medicine, like in all of history. Like it totally changes the paradigm on life, itself. And as we said before, there's a lot of capital flowing into the space, which is great for founders. But what we really need is just more people making the jump to join this industry, start companies, join longevity biotech startups, and so there's like a really urgent need for something like the On Deck Longevity Biotech Fellowship. Nothing like it really exists, so that's why I joined to create something that can just really increase the number of people working to build these companies.
I love that, and I think it works a lot with just the broader On Deck mission and ecosystem as well. Why don't we talk about the future? What's where do you see longevity going? What are some upcoming milestones, or what can we expect?
So I think the biggest change that we'll see in the next few years is that longevity will become sort of like mainstream. You already see this starting to happen. So interest in this space is rapidly accelerating. It's not just from investors, but also from governments who see the demographic issue with aging populations, but also just like broader society. People are popularizing this idea, and eventually it's just going to take on. It's just going to sort of accelerate. So, but more broadly, I think we're definitely going to see more clinical trials of anti-aging drugs over the next, I guess, 5+ years. Currently, there's only like maybe 40 clinical trials. Some are more related to aging than not, but we have like 100 different companies in this space, and they're all basically trying to bring a therapy that targets aging to the clinic. So a lot of these companies will eventually get to that point, and so we'll just see like an explosion in clinical trials for the anti-aging space. I think because of that, there's a good chance that the first anti-aging drug will be approved in this decade. It's really just a matter of taking enough shots on goal, and eventually one will be successful. And I think when we get to that point, sort of like the first 0 to 1 for an anti-aging drug, I think that will just totally shift the paradigm in society, and things will really, really take off in the longevity space. Some other things that we can look forward to, definitely the first trial with aging as the clinical endpoint. I think that's definitely going to be completed this decade. So Nir Barzilai at Albert Einstein College of Medicine is in the process of getting the TAME trial off and running, which is basically, this trial that will try to measure the effect, the anti-aging effect of metformin. And the clinical trial is designed to actually basically measure aging. And so that's their clinical endpoint. And hopefully we'll see the results of that in the next few years. And I think we'll likely find out whether some of these key approaches to developing longevity therapeutics will work in humans. Some of the things we talked about, like senolytics, which is the removal of senescent cells. There's a bunch of companies in that space, and there are already clinical trials for senolytics. So we'll probably find out whether this works in humans very soon. Other things like parabiosis, so the young blood or neutral blood dilution sort of approach. I think these are all that approach is going to be tested eventually in clinical trials very soon, and we'll see if that works. I'm really excited about that. Cellular reprogramming is really hot. I think that will take a bit longer, but there's a bunch of startups working on this right now. And there's also an interesting trial by Greg Fahey at Intervene Immune, which is basically trying to regenerate the thymus to reverse immunosenescence. And they're already in clinical trials, and I'm really excited to see if that works out. Well, it definitely seems to be able to reverse epigenetic age as measured by certain DNA methylation clocks. So that's it's really promising. But also like more broadly in terms of different modalities that are starting to become popular, just like in biotech in general. I think cell and gene therapies are definitely going to play a bigger role in longevity as well. There's companies in this space, but there's not that many FDA approved therapies for cell therapies or gene therapies. But the successes are starting to grow, and there's definitely a sort of appeal to gene therapies because it's more of like an information based approach to medicine, and you'll see that with like mRNA therapies and CRISPR and some other things like that. So that's really exciting. And I think another interesting area of longevity therapeutics that will take a bit longer to fully come to fruition, but are definitely super promising, is the idea of like regenerative medicine and tissue engineering. So there are a bunch of different companies working on lab-grown organs or xenotransplantation. So definitely check out like eGenesis, which is like a George Church lab spin out that's trying to grow organs from pigs, but like genetically alter them so that they can be used for transplantation in humans. I also want to bring attention to Jean Hebert's work. So he's a professor at Albert Einstein College of Medicine, and he has his own sort of startup project, which is basically trying to reverse aging in the brain by progressively replacing neural tissue. And I think this is just incredible because you don't have to worry about the different ways that the brain ages. You don't need to even know why it ages. You're just essentially replacing the tissue with young, undamaged tissue. And I think this is pretty much the defining bioengineering project of our time. So definitely check out Jean Hebert's work. So these are all like really interesting, approaches and different timelines for the future of longevity therapeutics. But it's hard to say exactly when all of these technologies will come together and be approved for use in humans. It's difficult to predict, but when people ask me when we will develop robust anti-aging therapies, I always say I'm not sure. But what I do know for sure is that it will happen one day eventually, and that it will happen faster if we get more people working on the problem. And I've basically devoted most of my time thinking about this problem, just getting more people involved. So yeah, I think it's a really exciting time to be working on the problem of biological aging. And I would definitely encourage anyone who wants to, work in a world-changing, sort of super revolutionary, high-impact field to consider, getting involved in longevity.
Yeah, and one thing I also want to make sure we get across this podcast. You were talking earlier about how Laura Deming had this call for founders, and one of the things she talked about is a founder that her and I have also have backed, Ben Kamens, who was the CTO of Khan Academy and was not sort of was new to the space and learned the space and then started a company and Spring Discovery and is doing quite well. And which is all to say that it's for people who are outside of the space as well. Can you talk a little bit about or talk more about why that transition shouldn't be as scary as it might seem?
Yeah. So we talked about Ben Kamens and some other people who came from like non-traditional backgrounds and founded incredible companies in the longevity space. And I definitely think that people perhaps self-select themselves out of the founder pool by saying, "Oh, I can't do it because I don't have the correct background." But I don't think that's necessarily a huge impediment. Like it's definitely possible to learn the biology. Others have done it before. Definitely check out Matt Schulz's interview on the Longevity Biotech Show podcast, where he talks about how he started from physics and computer science, and just read lots of papers, talked to a lot of people, and eventually started a couple different biotech companies and some in the longevity space, Weixin Biotechnologies. So it's definitely possible, and it's as long as you are passionate about this industry, then I don't think there's any reason why you can't learn the prerequisite knowledge and I guess connect with the right people to sort of mentor you along, tell you what to look for, sort of different sort of mentorship tips for starting biotech companies. And I think we're developing this fellowship at OnDeck specifically so that we can take people who come from non-traditional backgrounds, who are really passionate about this field, who want to make who want to start sort of these innovative longevity companies. We want to target these people and tell them, yes, you can start a company like this. Others have done it before. As long as you have the talent and you have the motivation, then we definitely want you to come and apply and be part of this community. We're definitely going to try and make it as easy as possible for you to get up to speed on biotech, biotechnology, with all the great mentors who have signed on board with our fellowship, and I think it's going to be really great.
Awesome. It's a great place to close. Nathan, thank you so much for coming on the podcast. Where can we point people to?
Yeah, sure. Just I guess follow me on Twitter. That's probably the best way to get in touch. My Twitter handle is real Nathan Cheng.
Awesome. And people can check out www.beyonddeck and find the longevity program there. Great, Nathan. Thanks for coming on.
Thanks for having me.
If you're an early stage entrepreneur, we'd love to hear from you. Check us out at villageglobal.vc.